Good afternoon, my YouTube viewers. It is Crystal here. I'm just here this afternoon because I wanted to make you a video. In my previous video, we did a random walk in Excel, and so in this particular video, I want to do a random walk in Python and also R. And the reason for that is because I want people or my viewers to know the three different ways that they can carry out a random walk. So Excel is something that you can do if you have the Excel software package, and Python you can do it if you've got Google Colab, and R is something that you can do if you've got my compiler. So there's these. Excel isn't free. If you get Excel, if you get like the Microsoft Office online, you may be able to get a free version of Excel that way. But I pay for Excel every month, so I don't get it for free. But you can try to see if you can get a free version of Excel and do it that way. If not, there's a possibility you can try it out on Google Sheets, which I haven't tried it on Google Sheets. I've just done it on Excel. So we've already done the random walk on Excel. So now what we're going to do is the random walk on Python using Google Colab. So in order to accomplish this task, you're going to have to import NumPy as NP, and NumPy carries out your numeric computations, and you're going to have to import matplotlib.pyplot as PLT, and what that does is that visualizes the data. And after you have imported the libraries, then what you want to do is you want to set your parameters. So in steps, I've set up for 100, and in simulations, I've set up for 1. So we're going to have only one simulation. So we're going to define the function for a single random walk. So def random walk is going to take n steps in, so it's going to take 100. Steps equals np.randomChoice, neg1 comp1, size equals n steps. So it's going to give you 100 steps, and it's going to be from -1 to 1, and -1 and 1. Position is going to be np.comSum steps. So that's going to be a cumulative sum of the steps. That's going to be your position. And it's going to return the position. So then we're going to do a one walk simulation because we're only going to do one walk on it. So one walk equals random walk in steps. So random walk is going to be 100. And the next thing we're going to do is we're going to calculate the mean of all walks and the variance of all walks. But I didn't do that right, did I? Because it's one walk, didn't I? So that's why it's always good for me to do a code review, because when I do a code review, that tells me what I did wrong. So I always, if I do a code review and I made a mistake in the program, then I'll pick it up on the code review. So I even got the variance wrong because I said one walks STD. So I messed that up. So try it again. Okay, we'll do that once more. Okay, and then what we're going to do is after we've calculated the mean and the variance, what we're going to do is we're going to plot the one walk. So PLT dot plot one walk, and it says PLT title Monte Carlo random walks. X label is step, Y label is position, and then we're going to show it. And then after we do the we make a line plot of that. We're also going to make a histogram, and the histogram is going to be plt.hist one walk. It's going to be 30 bins, and the H color is K, and the title is going to be distribution of one walk. X label is one walk, Y label is frequency, show. So now we'll show you everything. So the mean of one walk is negative 4.58, and the variance of one walk is 14.92. And so you can see this is our random walk. So like with every step, it's going to give you either a -1 or a +1. And it's going to 100 steps. And this is your distribution of one walk. This is a histogram of one walk, so that tells you what it looks like. So you can see what one walk looks like, and I'll just run it one more time. And so this is one walk, one random walk. And then what I did was I found the code for a random walk where it had 100 random walks, but I didn't want to use that, and the reason why is because I wanted to replicate as much as possible what I did in Excel, and what I did in Excel was just one random walk. So that's how we did it. And we could, like on Excel, it had 20 steps. So we can try it again with 20 steps and see what happens. See what happens when you've got 20 steps. So with 20 steps, it's just going down. And then with the bins, we'll have 20 bins for your 20 steps. And so the mean of the random walk is 1.8, and the variance of the walk is 2.65. So that's as close as possible to what it was on the Excel random walk, as you can see. And I didn't calculate the correlation coefficient, but I could give it a try and see what happens. So now what we're going to do is we're going to do it in R. So we had in steps was 100, but since we're going to try to make this as close as possible to what it looked like on Excel, we'll go ahead and make the in steps 20, and we'll run it again. And so you can see again what it looks like with 20 steps. And you can make as many steps as you want. I mean, I got some code for maybe 1,000 steps, 1,000 steps and 100 simulations. And I did that, and it also printed off like the first 10 of the 100 simulations. But that didn't actually replicate it didn't actually replicate what we did in Excel, so I didn't want to do that. So now what we're going to do is we're going to try out R. And R is very similar to Python, except for the fact that with R, you don't have to import any libraries, because all of the functions that you want are either you can make it in the program, which we have done, or they're hard-coded into R programming language. So we're going to say in steps is 20, and in simulations is 1. We're going to do one simulation. And this is a function for a single random walk. So random walk equals function in steps 20. Steps equals sample continuous. negative 1, 1. So it's going to be negative 1 and 1. Size equals in steps. Replace equals true. Position equals come some steps. And it's going to return position. So that is very similar to what was done in Python, except it was written in the R programming language. So now we're going to run a single walk. One walk equals random walk in steps, and it's 20 steps. So now we say mean random equals mean one walk, and var random equals var one walk, and you print that. And when you print the mean of one walk and the variance of one walk, you get a mean of one walk is 4.1 and a variance of one walk is 4.9. So now what we're going to do is we're going to plot one walk. So we're going to plot one walk. Main equals Monte Carlo one walk. And you don't have to import any library to do that. It's the visualizations are hard-coded into R. So this is what you get. So you can see it's going up. Okay, and then next thing that you're going to do is you're going to plot a histogram. And again, the histogram is hard-coded into our program. So I'm going to try to run this again. So you can see, here we go. Here's our line chart. It shows you what it looks like. And here's our histogram. And it shows you what it looks like in the histogram. So you have a choice. You can either use R with my compiler, or you can use Python with Google Colab. And in the previous example, we used Excel to make one random walk. So it's up to you what you feel most comfortable with, whether you feel more comfortable with Python or whether you feel more comfortable with R, which is what you would use. I mean, me personally, I feel more comfortable with Python because that's what I use, but you can also do it in R as well, and you don't have to import any libraries. So I'm going to go ahead and close this video because I've talked about everything that I want to talk about. One thing that I'm going to do after the video is see if I can find a way to calculate the correlation coefficient in this, because that's something else that needs to be done to make it similar to the random walk in Excel. But we did talk about Python, and we talked about R, and we talked about coding for Python and coding for R, and visualization techniques, the mean and the variance. And the reason why is when you're doing a Monte Carlo simulation, you want to get the mean and the variance. So that's it for this video. If you like my video, please like and subscribe. Thank you so much for watching my video. I look forward to making another video for you soon, and we will be talking about more technological subjects.